Good afternoon, everybody. Today we're back for part 2 of the Panelsaw side aligner misalignment error, where they had the panel go beyond the limits of the side aligner, rip the side aligner off. So we're back. The parts are in stock, and we're going to get that installed, get the machine back up and running, and find the underlying cause. Hang out to the end of it to make sure you get that, see what the underlying cause was. All right, so with that being said, let's jump to it. So we got the rollers here sitting on the table. You can see here, see how the arm is bent? That arm sits like this. Oops, excuse me, the roller sits like this. You can see where that arm is bent. That is supposed to look like this. Let's see if I can get it where you can see it. See how it's got a hook in it because of when it's mounted, it telescopes down. If I get this someplace so you can actually see it, it telescopes down like this. So it's got a hook to it. But you can see that angle right here where the shaft is parallel to the plate. And because the board got behind it, there's our angle, and then it bent it forward. So to straighten this out never is quite right. And what it winds up doing is it causes your roller, if you're looking down your cut line this way, it causes your roller to either be canted forward or canted back, causes your roller to prematurely wear. Then the mounting plate that we've seen from last week, this is the new mounting plate, and you can see that it's straight. This where you can see it as well, you can see that this one is straight. So I'm going to take a lot of these parts and pre-assemble them out here. I'm going to take this roller off. It's got the little snap rings to hold them in place, so I'm going to get that taken care of and get it all mounted and get everything roughly put together, so when I cross over into the inside of the machine that I don't have to keep coming back and forth. Alright, so I have pulled off the snap ring. You can see that there, pulled the snap ring off the end of this. You'll notice on a lot of these machines, the bottom side, which would be this, the bottom side is recessed so that roller can go down lower to the throw plates, and then the top sometimes is recessed, sometimes it's not. But what will happen is if you put this on upside down, you get a projection like you see, if you can see that one there. See where your shaft is here? See how it's projecting out past it. So what happens is when this comes down and lands down on the deck, in order for you to try to get that tighter, it winds up grinding in the deck, which we've seen that evidence in the back. So this one, whoever was put it on upside down. So what I'm going to do is get the other unit put together here. I've already got that snap ring out. Grab myself a punch here. Just going to tap that out. See how bad that's been. So you can see I was actually tapping that out, physically tapping it. And in a perfect world, you'd be correct to assume that I would not want to tap that because we'd be damaging our bearings. But these bearings here, you see here my little bearing, these bearings are not high speed. So if we tap on them a little bit, it's not going to hurt anything. But purely from a machinist point of view, you're correct that would not be the best thing to do. All right, so I've got my new shaft. I need to stop us where we're at here and go get this shaft cleaned up because it's got protectant on it from when they shipped it. We'll get that cleaned up and we'll be right back. All right, so looking at the adjustments for this, I was telling you that we can change this relationship here, and I have a square that we'll be able to set that up. But there is, you can see there, pair of set screws that go in. So when we mount these two bolts on here, this one becomes fixed, and you'll see that this hole is oversized. And we put a set screw in there to push on the bolt, this part of the bolt, and then we can tweak and tune this relationship. Okay, so the original, which is what this is, had the set screws. Somewhere through the course of time, when they've changed this out, it did not get transferred over, but we're going to make sure that it does on this install. These screws that's on these are not your typical grub screws. These are the ones that got the flat face on it. That way you don't blemish whatever it is, or you're less likely to blemish whatever it is that you're referencing against. Get that somewhat set close. That one in there set close. I'm just getting them, if you can see that, where they're just at the end of the hole. My plate is here. This is going to go in. That will suffice just fine. Now, the next question. Next question I have. When this goes in place, if I can get 2 snap rings on there. Looks like it. Let's give it a shot. Where's my snap ring pliers? There they are. Come on. Just snap ring on there. Snap ring is gripped on me. Like that, she's on there. Snap ring on that side, snap ring on that side, keep it from drifting. Ready to go on to the other side. Okay, we're back into the back again. Not sure how well you're going to be able to hear me. Got a dust collector off the one side, edge bander off the other side. But it is what it is. So this is where we left the machine at last week. I took this sensor, made a mark where it started at, dropped it down, found the position of the magnet so that when this was bound into place, this would not move. And at that point, parts were ordered. Obviously they've been received, and now here I am going to put this in. So what we're going to do is we're going to break these loose, physically pull this one completely out so it releases this guide. Take these out, take the end of our clevis off here for our shaft connection. Take it loose, slide the new one up in place. Now, when I was out on the front side of the saw and I was doing my pre-assembly of everything there, you'll notice that I left my roller loose. And I did that because on more than one occasion, I've assembled everything when I was sitting on a bench, and then I get back in here and I don't have clearance to be able to put everything together. So I did that because I had not taken this apart, so I didn't know how much room I had. You can see in here where these were marked in the past with permanent paint so that people would know if they've been moved, but this one was not. So that leads me to believe we're going to want to come in from this side, and if so, that extra length of your roller might be in the way. So that's what we're going to do. I'm going to set the camera down and we'll jump into it, see how it does. That's going to show up on camera. I'm not where I can see the screen. Just as I was afraid. I put everything together on it and I never get that roller in. For any length of time, you know I like this Loctite in the sticks because it makes it through the airport. TSA doesn't throw it away. It's a little bit pricier, but considering it usually winds up getting tossed out in a box and gets spread everywhere, from my point of view, it's better. So if you haven't seen this stuff, it's great. Your popular choices, they have the red, the green, the blue. Green's kind of hard to find, the retaining compound. They do have it in both the silver and copper anti-seize, and also have it in the Teflon. So instead of going through and putting Teflon tape on, it's kind of like a pipe dope kind of situation. It's kind of nice to have it carried with you. This one, when this telescopes up and down, this alignment here needs to be correct, so when it's telescoped up, that we're not putting this in a bind. So when I'm going to set these right now are going to be loose just a little bit. That crack, you see how that moved? Now when this strokes up and down, it's much easier. See how it's almost falling? Alright, they turned down the dust collector, so it got a lot quieter in here now. So basically, I'm using the no-load stroke of this when I raise it up and down to make sure everything feels good. Now, on to the tuning of the roller. Put me a little dab of doogie on here. My Loctite. Alright, so that is a little bit less than snug right now. Almost snug, but not quite. It's enough that this can still be tilted. Now when we go to bring this one in, this is the one the adjustment's done from. Bring that in less than snug. So right now, you can see this. You can get in where you see it. I have clearance between the bottom of this roller and the top of my throat plate. Because you can see this groove in here that you heard me talk about before, where the roller projected past it and it scrounged that. So all we want to achieve with this is that whatever our minimum thickness material, which, you know, let's say a 1/4 inch for instance, 6mm Luan or something like that, that sheet stock cannot get underneath that roller. If it goes too low, then you scratch your throat plates. If it's too high, the material goes under it. Okay, so drawer bottoms, 1/8 inch drawer bottoms, stuff like that, that's where that dimension comes in critical. So you remember when I put that roller on, the roller had a recess. That's what the recess is for. Alright, so now what we want to do is we want to go in with a square. Now this is a Machinist Square. Looks cheap, it's Chinesium, but this is not your average little POS combination square that we typically would use for doing our woodworking. This is actual Machinist Square. The ends of it, if you can see that, the ends of it are actually ground. This is ground, this is ground. There's a point, it's like a 60-degree point on there on both sides of it, and then the opposing tang are square. And then what that grinding on there allows us to do is that when we lay it down on the joint, and I may have to do it from the other side because I got the blemishes in the table, when you lay that on there, we bring this up and then it makes a crisp line in here. Now you'll just have to take my word for it, because I can't hold the camera and the flashlight and make adjustments at the same time. But when we shine that in there, you'll see a crack of light. That's why they grind them. It's because that crack of that grind causes your crack of light to. Let me get in the right camera settings here. Bear with me. Let me get rid of all this. I have to do this with my phone because I don't have my flashlight with me. Alright, so I don't know how well that's going to show up on camera, but can you see? Let me get my pointer. Can you see here? See where I'm touching at the bottom? I'm open at the top. With those screws being snug, any adjustment that I'm going to do is going to be a underload adjustment. Back that off a little bit. Take this one. Yeah, did you see that move? Now we go and check that again. You keep moving that. See that move? There we go. A little bit more. There. Can you see that now? I don't know if you can see from where you're at, but from where I can see that plain as day. That this joint in here, I no longer have a crack of light. See where I back that up? You got a crack of light, and I bring it forward. and the crack disappears. That's the purpose of the grind. And these Machinist Squares are not terribly expensive. Alright, so now that I've got that set, let me get the phone out of the way here so that I don't drop it. I'm going to tighten, bring it back down, turn my light back on, make sure that what I did not alter square, and it did. So, break my top loose, not too loose. I need to bring the bottom back over now. It's okay, this is why we do our testing. We test and we confirm, and we test and we confirm. Take this one off a little bit. This one in a little bit more. Oh, too much. Back that one off. Alright, now tighten her back up. I think I'll leave the light there for just a second. We tighten that up, we check it. Close enough. Now, last thing to do before we climb out is I need to put this sensor back into its correct position. I'm comfortable from the adjustment that I had before that I can put it back in the same spot. So again, this is a magnetic reed sensor. For you, quick recap for those that don't know, inside this, where your piston is at, is a magnet. Inside this sensor, it's a pair of contacts that close when the magnet goes by. So it sees the position of the sensor based on a magnet and a reed switch. You'll see on here I have two stripes, and so when I was positioning this, that the magnet that's inside seems to be about 10 millimeters, maybe 12 millimeters wide. So as this sensor is going up and down, there's a area that it can see, but if it goes too far one way or the other, it doesn't see it. So I made references for the high and the low, position in the middle. When I undid it, I put two marks on here for where the up position is. So in theory, I loosen our clamp back up, move it back up, we should be in the same spot. Alright, so let me get my square out of the way, my pointer out of the way, set you back down. I will make that adjustment real quick. Make sure you're still in frame. Yes, you are. Alright, just like that. Now that everything is put together, this sensor sees that the gripper, side aligner is up, so that if the grippers, is what I'm setting on, if the grippers come forward, the potential that they would collide into the side aligner, that is the check and balance. So what we have over here on this side, over in here, we have a set of switch rails with some switches that's on top. And if that switch is on that cam, which means the pusher is forward, it looks to see if this is up. If this is not up, the pusher will not continue forward, and that keeps it from happening where the gripper, excuse me, what it's supposed to do is keep the gripper from hitting the side aligner. Alright, so now there is a check and balance in this. There is here, let me find my pointer. We can get over to it. Sorry for shaking the phone there. See that hole down there? That hole? Right there. That hole has got a sensor in it. Some machines have that sensor in the bed, in your throat plates. Some of them have it in the fence. Doesn't really matter where it's at. What matters is that it's there. So that is a material presence sensor. So if this sensor is off and this switch here is hit, this does not work. Okay, so what it does is disable this if there's no panel present. If it sees a part, this is enabled. If this is enabled and that switch rail is hit, this pusher, the entire mechanism, stops. The problem that we have right now is that sensor appears to be misadjusted or calibrated wrong. I think it's just misadjusted because it's way back in there. That is, should be at a capacitance sensor. So it always thinks that a board is there. Okay, so what happens is, let's say that I tell the machine that I'm going to do a pullback on a part that is 96 inches long. It pulls with the pusher, goes back however far it needs to go to accept that 96 inch piece, or maybe it's 84 inches, whatever that value is. But if I introduce a part that's wrong, so let's say I would put in a 60 inch piece instead of a 74, or I put in an 80 instead of a 96, what will happen is the short fence that's in the back, the squaring fence, when the pusher pulls back, it comes off of that sensor, and then because it's off that sensor, when this comes forward, that sensor is off, this is disabled. In this scenario, that sensor always thinks there's a panel there. So what happened was, this side aligner stroked over, got on that side of my panel because it had too short of a panel in it, continued going past the edge on the other side, so as the pusher started to move the material forward, it grabbed this side of your side aligner, and the rest is history. Okay, so we've got this put together. We're going to energize the machine, check our up sensor to make sure that's correct. When I did the diagnostics, I had a alternative power supply, which is a little 9-volt battery box that powered that sensor so I could be in here safely with the machine locked out. I didn't do that today because I already know all this stuff works. But here shortly, we're going to energize the machine, wait for everything to come along, turn the air on, watch this go up, and our sensor here, our read sensor, should go high. So that's where we're at. I'm going to stop you here, climb out of the machine, gather all my tools, fire everything up, and we'll pick it back up here in just a moment. All right, so the machine is under power, computer is up, and you can see now I have my sensor. Okay, everything's live right now, so I don't want to climb in there to be able to get a closer look from that, so I'm just kind of standing on the ladder, leaning down in there so we can see it from the front side. But you can see there where the sensor is on. Okay, so I'm happy with where that's at. Now what I'm going to do is take a look at that sensor down there. All right, so let me go over there, see if we can get this down here where we can see it. Sensor down in there, got the red light on. There's no material in front of it. So what we have to do is take the horizontal alignment and bring it out a little bit. But I don't want to do that with where the pusher and everything's at because I need to be right here to work. So I'm going to bring it out, hook up my little battery pack to it, go down in the cabinet, unhook my wires, and go from there. Alright, so I've mentioned several times about having the machine locked out running off a battery pack. Inside this box, this is a Baumer unit, but there's several brands. Let's see if I can get in there where you can see this number. It's a number 11084377. Uses two 9-volt batteries, which I know system's 24 volts and two 9 volts is only 18, but that is enough power with the tolerance of the sensors to energize that circuit. So then what you do is you go lock out your machine, make it energy safe, and then you disconnect your sensor wire, or depending on what kind of sensor it is, if it's one of those that has the M12 or M8 ferruled connection on it, you disconnect it, connect that, and here you'll see across the top of it, you see this one says plus, and we have a blue one that is neutral. It says ground here, but it's neutral. And then a black one says output, and a white one that says teach. So if you ever look at your 4-wire sensor cables, you just hook up the color codes. Whoop, almost dropped it. You hook up the color codes to this, and if you have one of the sensors that you can teach its processes, whether it's normally open, whether it's normally closed, or sensitivity, or all the little things. There's some of the sensors are extremely intelligent. That's when you would get in here with the teach function, and you can teach it to do whatever it is you want. From my diagnostic standpoint, I energize it with the plus, the ground, and then I use the black wire for the neutral. If the white one is there, I go ahead and connect the white. A lot of times it's not. That allows me to run that sensor from this box and be OSHA compliant. And that makes a lot of EHS people happy. All right, so that is my shameless plug for the day. All right, so I'm going to lock this out, climb up over the top of that, and get everything set. All right, so I've made the adjustment to this sensor. You see now the light is off. When I block this, the light comes on, off, no material, side aligner is disabled. Has material, side aligner is enabled. This adjustment, I brought this forward. Right now it's recessed back about 1 millimeter or so, maybe 1.5 millimeters. It's not very finite, because it really doesn't care. But that material sensor does a couple things. One is the side aligner like we talked about. Also, if you have an auto absolute measurement, when the material goes past, it's looking for this sensor. So as the material goes past the end of it and it's coming forward to do your first absolute cut, sees that sensor. Once it sees the sensor, it knows the distance from this sensor to the cut line, continues moving your panel forward. That way you don't have to measure every single part. Okay, but that service that we just did there took me less time than it did to shut down the machine and lock it out. So a 1 minute correct adjustment for this would have stopped that. Okay, now what we're going to do is bring everything online, calibrate the machine, hand the machine over to the operator, and let them do some test cuts. Okay, that was it. Nice easy one today. Took us longer to drive down here than it did to fix the machine. And as of course would have it, get down here and talking with the owner of the machine, and we find a couple other things that we're going to come back and address on our next service call. So as always, preventative maintenance on this moving forward is going to make our machine last longer. This machine is I want to say it's a 2004 or so, something like that. So it's 18, 20-ish years, so I can't remember when we put it in. But it's lasted this long because they take care of it, even though, you know, here we are replacing a part. So with that being said, guys, as always, go out there, be safe, and let's go make a million.